Every single day, just one factory in Texas produces 15 million Snickers bars. That's enough to stretch over 700 miles, nearly New York to Chicago. Picture this fluffy nougat melting on your tongue like sweet clouds, gooey caramel perfectly balanced between sweet and salty, studded with crunchy roasted peanuts, all wrapped in velvety milk chocolate, so smooth it dissolves instantly. This irresistible combination was created by Frank Mars in 1930, named after his family's beloved horse. Nearly a century later, Snickers isn't just the world's best-selling candy bar. It's a cultural phenomenon in over 70 countries, with sales exceeding $2 billion annually. So come along as we uncover the secrets behind every layer of this legendary candy bar, from roasting ovens to chocolate waterfalls, witnessing a manufacturing process so precise it rivals a Swiss watch factory. Our journey begins under the blazing sun of Georgia and Texas peanut farms, where runner peanuts grow in sandy soil. Here's something surprising. Peanuts don't grow on trees. They develop underground, beneath thick root networks. Specialized harvesting machines dig beneath the soil, lifting entire plants, shaking off sand, and collecting peanuts into massive one-ton bags. The challenge: timing. Too much moisture causes mold. Too dry, and they crack during roasting. Farmers must harvest at precisely the right moment, 120 to 150 days after planting. Meanwhile, across the Atlantic in West Africa, cocoa farmers harvest beans using machetes to cut down pods from 30-foot trees. They split them open by hand, revealing 20 to 40 beans in sweet white pulp. Each farmer tends 2 to 3 hectares, producing 600 to 800 kilograms annually. These ingredients, American peanuts, African cocoa, Midwestern corn syrup, converge at the Master Foods facility in Waco, Texas, where the magic begins. The magic begins in a temperature-controlled room where cocoa beans meet modern machinery. Specialized deshelling machines crack open the hard shells using calibrated steel rollers. Shells fall through vibrating screens while precious nibs continue forward. The nibs then enter an industrial rotating drum heated to 370 to 140 degrees. For 8 to 20 minutes, they roast continuously, unlocking deep chocolate flavors as bitter compounds break down and aromatic oils release. Next, massive granite wheels, weighing several tons, crush the roasted nibs into thick chocolate liquid. The friction generates heat, liquefying the cocoa butter within. This dark liquid is combined with sugar and milk powder, creating a grainy mixture. The mixture passes through a 5-roller refiner, crushing particles to less than 20 microns, smaller than a human hair. This creates that signature smooth texture. From there, it enters the conchage, where metal arms churn the mixture for up to 12 hours. Additional cocoa butter and lecithin transform the grainy paste into silky liquid chocolate. Finally comes tempering, the most critical step. The chocolate is heated to 113 degrees, cooled to 81 degrees, then raised to exactly 80 degrees. This precise temperature dance ensures the cocoa butter crystallizes properly, giving the chocolate that perfect snap and glossy sheen. As the chocolate tempers across the factory floor, the peanut roasting operation runs simultaneously. Those massive 2,000-pound bags of raw runner peanuts are hoisted by crane and emptied into a stainless steel hopper. Gravity feeds them onto a conveyor belt. But here's the clever part. The peanuts transfer onto an oscillating conveyor that rocks back and forth at 30 cycles per minute. This ensures each nut receives perfectly even heat exposure. The peanuts enter a massive 150-foot convection oven where precisely controlled air circulates at exactly 350 degrees. For 30 minutes, they tumble through their starches, converting to sugars and oils, releasing those irresistible nutty aromas. Here's a mind-blowing number. This factory uses approximately 100 million pounds of peanuts annually. That's equivalent to 21 acres of farms working full-time just for this facility. As they exit the oven, workers spread them on cooling conveyors, preventing clumping. The peanuts then pass through a rotating drum where fine salt mist is applied through precision nozzles, adhering perfectly to the warm surfaces. While peanuts cool, master candy makers prepare the gooey caramel in the kitchen area. The process starts in an 800-pound industrial vat where corn syrup, butter, condensed milk, sugar, and salt are precisely measured and combined. Too much sugar creates graininess. Too little butter loses that luxurious mouthfeel. The mixture transfers into a vacuum kettle, a copper pressure cooker that heats the caramel to 200 degrees for exactly 20 minutes without burning. This is where chemistry becomes art. Sugar molecules break apart and recombine through caramelization, creating hundreds of new flavor compounds. The mixture shifts from pale yellow to deep amber, releasing intoxicating aromas of toffee and butter. The candy makers must monitor consistency, constantly looking for the softball stage, when a dollop dropped in cold water forms a soft, pliable ball. Too long and it becomes brittle. Not enough and it's too runny. Near the end, vanilla extract enriches the flavor while lecithin keeps it smooth and stable. The entire process takes 45 minutes. Once perfect, the molten caramel, still steaming at 200 degrees, flows through a discharge valve into a waiting vat, ready to meet those roasted peanuts. In another section, craftsmen create the cloud-like nougat layer. Inside a stainless steel vessel, corn syrup, sugar, salt, and water blend and heat to precisely 200 kPa, creating an intensely sweet syrup. But this is just the foundation. Here's the magic. This hot syrup is poured into beaten egg whites, whipped to stiff peaks. The heat denatures the egg proteins, wrapping around thousands of tiny air bubbles, creating a stable foam that's light yet structurally sound. The mixture is stirred at high speed and cooked further at 270 degrees. The candy makers seek a specific consistency, firm enough to hold shape, yet pliable enough to bite easily. The challenge: atmospheric humidity. Too much moisture in the Texas air causes the sugars to pull water, making nougat sticky and unstable. On humid days, candy makers adjust temperatures upward by 10-15 degrees, relying on years of experience. After achieving ideal fluffiness, the nougat transfers to a massive screw mixer where it meets freshly ground peanut butter made on site. This infuses each bite with extra nutty richness, turning the mixture from white to pleasant cream color. The blend then travels along an elevated conveyor across the factory top, cooling gradually from 180 degrees to a workable temperature. This elevated highway saves floor space while allowing natural cooling. By the time the nougat peanut butter blend completes its elevated journey, it's ready for transformation. The conveyor deposits the warm mixture into a large hopper where gravity takes control. It drops between two massive rollers below, each chilled to a frosty 24 degrees. This machine, called a sheeter, performs dual functions, pressing the mixture flat while rapidly cooling it. As warm nougat meets frozen metal, something fascinating occurs. The sudden temperature shock causes a thin skin to form on the surface, sticking momentarily to the cold rollers. This is exactly what engineers want. It controls the final width and thickness. The rollers rotate continuously, and a precisely positioned blade scrapes the cooled nougat off, letting it settle onto a stainless steel conveyor below. The result: a perfectly uniform sheet exactly 0.5 inches thick, ready to receive its caramel cream. Now comes the moment when separate elements finally unite. That hot caramel from earlier has been kept warm in holding tanks. It's poured into a depositor feeding into a screw auger, essentially a giant corkscrew that continuously turns and mixes. At the exact same moment, those freshly roasted salted peanuts cascade from their conveyor into the warm caramel below. The auger turns, relentlessly folding peanuts into gooey caramel until every nut is perfectly coated. This sticky mixture is pushed forward, emerging from the auger and cascading onto a giant rotating metal drum. Another cooling roller chilled to 24 degrees. Here's why this matters. The caramel is still too runny to hold shape. The cooling roller spreads it into a thin, even layer, while dropping its temperature, transforming liquid into workable sheet. After one complete revolution, a large blade scrapes the caramel peanut layer off. And here's where precision engineering shines. The scrape layer falls at exactly the right moment to land directly on top of the nougat layer moving below. Together, they pass beneath a pressing roller that gently but firmly squeezes them into a single unified slab. The pressure must be perfect. Too much compresses the nougat, losing its fluffy texture. Too little and layers won't bond. The combined slab enters an enclosed refrigerated tunnel, cooling to a stable 65 degrees over several minutes. This allows layers to harmonize flavors, melding while the structure firms up enough to be cut without deforming. After emerging from the cooling tunnel, the massive slab encounters its first transformation, the slitter machine. This impressive equipment features 19 rotating circular blades, each honed to razor sharpness. As the slab passes through these blades, efficiently divide it into 38 parallel strips, each destined to become multiple Snickers bars. The strips continue forward, and here's where it gets really satisfying. They encounter sharp guillotine-like blades that slam down in rapid succession, thunk, 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 slicing through each strip perpendicularly. In just 5 seconds, what was once a single long strip becomes dozens of individual bars, each measuring exactly 4.52 inches long and weighing precisely 52.7 grams. The consistency is remarkable. Thanks to computer-controlled pneumatic systems, variation between bars is less than 1 gram. These perfectly portioned bars march forward, ready for their final transformation, the luxurious chocolate coating that will seal in all that deliciousness. Let's circle back to that silky, tempered milk chocolate that's been patiently waiting. The chocolate, now perfectly tempered and flowing, like warm honey, is directed into 2 separate enrobing machines, essentially chocolate waterfalls designed to completely coat each bar. Bars first pass through the bottom enrober, gliding over a shallow pool of flowing chocolate that coats their undersides. This creates the foundation layer, ensuring no gaps when they flip over. Following that, they proceed to the full enrober, and this is where magic happens. Imagine a curtain of cascading chocolate falling in a perfect sheet. As each bar passes underneath, it's completely submerged in this flowing chocolate waterfall, emerging entirely coated in glossy, velvety chocolate. But it's not finished yet. The chocolate coating is still soft and uneven. Bars move across ingenious vibrating grates, shaking at 60 vibrations per second. This constant motion distributes chocolate evenly across every surface and eliminates trapped air pockets. Now comes a detail you've probably never noticed. Bars pass under a decorative roller machine that imprints each Snickers with its secret signature swirl pattern on top. It's subtle, but next time you unwrap one, look closely, you'll see delicate wave-like patterns. This isn't just decoration, it's a quality control marker identifying authentic Snickers. Freshly coated bars enter a final cooling tunnel where carefully controlled airflow at 60 depth allows chocolate to solidify gradually. Rush this step and the chocolate develops dull, streaky bloom. Do it right and you get that perfect glossy finish and satisfying snap. After their cooling tunnel journey, Snickers bars emerge fully solidified, perfectly formed, and ready for the world. Each bar is carefully inspected by human eyes and computerized vision systems. High-resolution cameras scan every bar, checking for imperfections, uneven chocolate coating, misshapen edges, incorrect weight. Any bar not meeting strict standards, tolerances of just 2–3%, is automatically rejected and sent back to be reprocessed. Approved bars enter the wrapping machine, a marvel of mechanical precision. Each bar is enveloped in that iconic brown and blue wrapper, specially designed plastic film creating an airtight seal, protecting candy from moisture and oxygen. The wrapping machine, equipped with heat sealing technology, processes up to 1,000 bars per minute, working so fast, individual bars blur into a continuous stream. From wrapping, bars are automatically sorted and packed into boxes. 48 bars per box, then stacked on pallets and wrapped in protective film. Each pallet holds 4 and 32 bars weighing over 200 kilograms when fully loaded. And from this single factory in Waco, Texas, approximately 15 million Snickers bars ship out every single day. They're loaded onto trucks headed for distribution centers across all 50 states and exported to over 70 countries. From gas stations in rural America to convenience stores in Tokyo, From supermarkets in Brazil to kiosks
No
in
matter
Paris,
where you are,
this is truly a
taste
global
of satisfaction
operation.
is
Here's a fun
always
fact you
within
might
reach.
not know. Snickers bars originally sold for just 5 cents when they launched in 1930. Adjusted for inflation, that's about 90 cents today. Not bad
I'll
for
have one
what
of those
was
Snickers.
essentially a
Right
meal
here, that's 5
replacement
cents.
during the Great
Much
Depression.
obliged.
Each Snickers contains approximately 250 calories, 12 grams of fat, 33 grams of carbohydrates, and 4 grams of protein. That protein from peanuts and milk chocolate makes it genuinely more filling than many candy bars. For me, there's something deeply satisfying about understanding the journey behind products we often take for granted. From sun-drenched peanut farms to precision chocolate tempering, from careful caramel cooking to that final signature swirl, every single step is executed with remarkable care and engineering precision. So here's my question for you. What's your favorite way to eat a Snickers? Do you savor it slowly, layer by layer, or bite right into the middle, mixing all those textures and flavors in one glorious mouthful? Drop your answer in the comments. I'm curious to see if I'm the only one who freezes them first. Thanks for joining me on this delicious journey through the Snickers factory. If you enjoyed this deep dive into how your favorite candy is made, give this video a thumbs up and subscribe for more fascinating looks inside the factories creating the products we love. Until next time, stay curious and maybe grab a Snickers while you're at it.